So for Canonical I've been working on getting Optimus support into Quantal, and also been working a bit upstream on trying to get it working right for us. So my presentation is going to be a bit about all the pieces that are part for making Optimus work, and what also a small bit about what needs to be done still. So yeah, first, all the things that are involved in Optimus. The first part is really big, it's DMA buff. The second part is the XORG server, the individual drivers that needs to be enabled, and the XRender stuff for configuring of the drive and the X server for it. So yeah, DMA buff. All the drivers have to be modified so they can accept DMA buff FDs, and then also emit them so they can export and import DMA buff FDs. DMA buffs are simply just a way to say this is a special kind of FD, and you can do some system call to enable it and export it to some other buffer. And usually for now, all the DMA buffs are pinned into memory, so in main memory, so you cannot use video RAM or anything like that. And as it stands, there's no synchronization being done, so there's no guarantee that when you complete your DMA buff on one device, that when the other device starts, the running has completed or not. So the only way to do it would be to stall the first GPU and wait for it to complete. And that's really not optimal. So that's the part where I've been working on. Also, yeah, all the stuff that needs to be done in the XORG server, the DDX and XRender. First of all was the platform bus support. I don't know much about it. Keith probably knows more than me. But it's basically for enabling GPU hot plugging. And it doesn't necessarily have to be GPU, could also be, for example, a USB device like those display link monitors. Yeah, XRender 1.4 is used to configure all of that. So you can set a device and then select the property for being what it is exactly and what it's going to be used for. And it can change over time. So yeah, each DDX needs support for platform bus, but also support to being output slave. Output slave is simply a device that is only used for rendering. So, for example, those USB devices don't have any logic to do any GPU accelerations, but they might have some code so that you can transfer it to it. And then you export a DMA buff from the Gintel card and put it on your mode setting. And then you can display your rendered buffer on the USB device. And Intel is also going to be useful as an output slave, because in the case where you have Optimus and you have a laptop, it might be that you have a second output that's only enabled on your NVIDIA card or ATI card. So in that case, you still have the panel, and that's usually driven by the Intel card, unless you have a multiplexer between, so it can switch between it, but that's also not really supported yet. So yeah. There's also the offload slave, and that will be the card that does all the rendering. And in that case, you can have, for example, that one card drives the display, but you have a powerful GPU that's not connected to any display, like ATI or NVIDIA, and then it does all the rendering for you. And of course, being the master, and the master is simply the ones that support the slaves and drives them. And for X1.13, the idea is to also be able to support multiplexed GPUs and then be able to switch between them. And for that you need some robustness extension, and that basically tells the compositor that if the compositor enables it, it can tell it that the GPU suddenly disappeared and you need to create a new OpenGL context. And also, yeah, just all the X server has to be modified so you can switch between GPU screens. And then preferably in a way that it looks the same as on MacBook, that you don't even notice that you switch between the GPUs. Yeah, that's still work in progress. And yeah, the problem for synchronization is that you have multiple devices and they have any number of buffers in any order that they can take the buffer. And you want to do it in such a way that you don't get any deadlock between the CPU, the devices, and anything that's going on. So when one takes a certain amount of buffers and the others you can enter a deadlock. And that's what I've been describing here. You have two devices, A and B. They both export a buffer and they import each other's buffers. And yeah, so they try to use it and one grabs the first buffer, other grabs the other buffer, and then they wait for each other. And that's really why you need some kind of reservation mechanism, so they take all the buffers or none. And this doesn't necessarily have to happen on the CPU. It could be that, for example, the card has to wait for the first buffer to finish rendering, and the other has to wait for the other buffer to finish rendering. In that case, you would also get a deadlock. And that's what really the solution is: steal the TTM style reservations. That's really just picking all the code from TTM that's dealing with reservations. And a reservation is simply saying, I have a number and I want to grab everything with that number. And it could be that someone else has a number too, and in the case that they get a lower number, you simply wait for them. And if they have a high number, you have to start over again and unreserve everything, or something like that. It could be messed up the order, but that's basically how it works. And then, in that case, you either get a complete set of buffers or none at all. And because it's all sequential, there's no way you can deadlock anymore. So yeah. And for that, it would be nice to have some kind of primitives that makes it easier to annotate everything. So you get like a fence. That's basically what TTM fences are, but they're no longer constrained to one single device, so it could be shared between multiple devices. And you have a reservation ticket, and that's basically what the number is I'm talking about, but in a way that it makes locked-up annotation a lot easier. So yeah, the fence API is even a work in progress. I used to call it like DMA fence, then I called it TTM fence because the TTM guys wanted it. Now I'm simply calling it fence because, yeah, it doesn't make sense to give it any specific name. And yeah, it's the dumbest primitive you can think, because it's just saying block until the fence is signaled, and you have to manually signal it unless you have some special hardware in place. Because it could be that you create a specific fence. For example, you have a system on a chip that has an interrupt line that can signal between the GPU and a video decoder, and then you can use that mechanism, but your software still needs to be aware that it's possible. Yeah, and you could have the concept of exclusive fence, that's only one per device, or shared fence, that if you are reading, you might want to be able to have multiple readers on the same data. For example, if you have a camera on your phone and you want to output the data from your camera to your screen, and also use it to encode it in some way. So yeah, that's the fence API itself. That's going to be used for the reservations. And the reservation API is similar. It was also originally called DMA API, then TTM reservation API, and now simply reservation. And you have a reservation object, reservation ticket. And yeah, I've been working on adding locked-up annotations. It's similar to Daniel's Vetter's patch, where you have the console mutex that's not really mutex, but acts like one. It's similar for the reservations. There's some kind of lock, and if you do the locking wrong, you can deadlock in some way. And yeah, like I said, the reservation ticket is for multiple objects. So you first create a reservation ticket, then you try to reserve all objects, and then you either have to cancel your ticket, or if it fails, and start over again, or you complete it and then you enter the ticket in a similar way. And the reservation object is really the primitive I was using for the stuff you can reserve, and that's really the same for every object you make. And there's some slots where you can put in the fences, so you know when the previous work on it is done. Eviction support is still not done yet. I've been working on it a bit, but it requires some interaction with the TTM, and that's really a lot harder than it should be sometimes. Yeah, and here's simply the rules about fences. You create an object I called ob here, but it's really when you have a reservation and you want to signal you're done. It might not be while you're holding the reservation. In that case, you have to create a fence. And it has to be done after you reserved and before you unreserve the buffer. And the fence can be attached to multiple objects, so you only need to create one single fence. And you have multiple shared slots and one single exclusive slot. And this all other rules simply follow from it. When you have a shared slot, you have to wait until the exclusive slot finishes before you can start processing. And when you have a exclusive slot, you have to wait for all the previous fences that are in there to finish. I think, yes, now it's time for the demo. That's really, I've been working on it a bit, and I don't have the complete set working because it's just, like I said, without synchronization. This is just what I was proposing. So let's see if the demo works. Yeah. First off is trying without on the Intel card, and then I'll just try to show it that it shows just the Intel card. And then I try GLX info again, but with Nouveau. And we spawn off some GLX keys, because that's our favorite thing to show, right? As you can see, it's still having a bit of problem, not using the latest Intel driver yet, so there's some bug in there where it's not really going smoothly. So let's have a normal GLX case with Intel. So that's really what I've been working on. Yes, you can see it's not really working right. But that's the only way. Oh, it crashed? No, yes, it did crash. I had to update to Quantal for this because all the pieces were not in precise yet, but this is all just from base Quantal, no patches or anything. So it still works in progress. Let's see. Nope, it's deadlocked. The whole system's not responding anymore. That's why I put it in, so there was one more slide and that basically said if there are any questions. So we didn't get to that, so. Anyone?
Did I got that right that you extended the fencing mechanism of TTM to not only got one fence per buffer, but
yes,
multiple ones, where you can say, okay, I got 6 readers and just one writer?
Yes. So you can have one buffer and then 6 readers on it if you want.
Sounds good. You actually solved some problems for me on Radeon.
Yes. But it's basically, TTM doesn't have any support for it yet, but it's basically in the case where you have multiple devices where you want to use it on. So DMA buff is not really constricted to just GPUs. It can also be used for USB webcams if they can go to arbitrary memory. Basically anything you want. And that's similar for the fences. They might be some hardware specific thing.
Just curious, what is the use case for having read and write fence?
Well, basically, like I said, it's when you have one person writing from a camera to some buffer, and you might have something that wants to display it on the screen, and you might have something that wants to decode it to the hardware, and you might want to do both at the same time. In that case, you don't want to wait until it finishes showing on the screen. You don't want to wait until it finishes showing on the hardware. So they both read from it at the same time.
Okay.
Well, I guess the most common use case is like a separate video encoder or
yes,
decoder which needs all the reference frames around, but you want to use them on another fence. And if you just keep one fence around, you kind of wait always for everything and single step everything because because of the looping behavior of the encoder or decoder with the reference frames, the snake bites its tail essentially.
Anyone? Okay, doesn't look like we have any more questions. Thank you very much, Martin.